All right, so here we have some more production possibility practice. And so we have two different graphs here that we're going to be looking at. So let's just run through this first one really quick. I went ahead and already plotted out these points where we can be either producing headphones or radios. That's what we've got going on here. So it says to us first, it says draw a point with the coordinates of 2 radios and 10 headphones. So 2 radios and 10 headphones would fall right there. And it says label that point Z. What can we say about that point? Well, since that point falls inside of our production possibilities curve, we can say that that point is, what we can say about it is it's attainable. Like, yeah, we can get that point. We can make that combination, but it's inefficient, right? Attainable, but it's inefficient. Now it says then, hey, let's find a point that is 4 radios and 30 headphones. So that'd be a point that is approximately right here. We're going to call that point X. And it says, what can we say about that point? Well, since that point falls outside of our production possibilities curve, we can say it's impossible, right? We can't achieve that point because we don't have the resources available to us. Now let's look at these other questions concerning opportunity cost. It says, what is the opportunity cost of our first 3 radios? Now we have to pay attention to the language. It says our first 3. And so we obviously assume that's the way it's worded. Since it says our first 3, we haven't made any yet, and we're going to start making up to number 3. So that tells us that we should be starting here at point A, and we'll end up where we have 3 radios, which is here at point D. And so we're moving from point A to point D, where we add 3 radios, but remember, our cost is what we have to give up. And if you notice, we would go from producing 50 headphones down to only producing 26 headphones. So how many headphones would we be giving up making? Well, 50 minus 26 is 24. And so therefore our opportunity cost is 24 headphones, because we would have to stop producing 24 headphones in order to start producing those 3 radios. All right, what's our opportunity cost of moving from point E to point C? And so this is another one where it's giving us 2 points, and we have to be very careful in following the direction because it says we're going from E to C. And so again, we have to pay attention to the direction we're moving, because what are we gaining and what are we giving up? Well, if you notice, we're gaining headphones, right? We're going from 14 headphones up to 36, and so we're actually gaining 12 headphones in there, but opportunity cost, or just any cost, is what we have to give up. And if you notice, our number of radios would drop from 4 down to 2. So we would be giving up 2 radios. So our opportunity cost is 2 radios. But again, it's because we're moving from E to C. We have to pay very close attention to the direction that we're moving. So 2 radios. What is the opportunity cost of our 3rd radio? Now, again, paying attention to this language, when we say our 3rd radio, we hear 3rd, we got to think like, okay, we're moving from what number to what number? And the way I like to think about it is just in terms of food. You know, if I'm going to eat my 3rd piece of pizza, you assume I've already had 2, and I'm going to eat 1 more. So I'm moving from 2 to 3. And so when I add that 1 radio, I am giving up how many headphones? What am I losing? Well, 36 down to 26, I am losing 10 headphones. All right. Would we describe this opportunity cost? How would we describe it? I guess I should say. How would we describe the opportunity cost of this production possibility curve? Well, looking at graphically, we can tell it's not quite linear. It does bow out a little bit, but it does so for a very important reason. What I want us to notice is, let's think about this. Every single time we add 1 radio, if you notice here on our table, we're adding 1 radio, plus 1, plus 1, plus 1, every single time. Remember, our opportunity cost is what we have to give up. Well, let's check. For that first radio, from 0 to 1, we have to give up 6 headphones. Then the next time we have to give up 8 headphones. Then the next time we have to give up 10 headphones. And what do you notice is happening to the number of headphones we have to give up each additional time? Well, it's increasing. And so therefore, we can say that our opportunity cost is increasing. And the reason that we know that is because when we look up here at every single time that we add a radio, what we have to give up in terms of headphones, it's rising. It's going from 6 to 8 to 10 to 12 to 14. it's increasing. And that's why we can end up seeing a little bit of a bow in our production possibilities curve. It's not quite straight because that slope is changing along the production possibilities curve. Now let's look at that back page really quick. So I already went ahead and again plotted out these points, and we have corn and soy here. And it also says to graph a point as M that is considered unattainable. So M can just go anywhere out in that red area, anywhere outside of our production possibilities curve. And then it says a point P that is attainable but inefficient. And again, that would just be anywhere inside of our production possibilities curve. Now looking at these questions, what I actually think it's helpful to do first, because this is what I like to do. What I think it's helpful to do first is go and answer these two questions first. Our opportunity cost just for a single pound of corn and a single pound of soy, because it's actually going to help us solve some of those other questions. And so if you remember from our 1.3 practice, we know that our resources, if we were to take all of our resources and put them just toward corn, we could produce 40 pounds of corn. And if we put all of our resources just toward soy, we could produce 30 pounds of soy. So those same resources it takes to produce 40 pounds of corn can produce us 30 pounds of soy. But if we want this just to know for the opportunity cost, or what we'd have to get for just 1 pound of corn, what do we do to both sides? Well, we can divide both sides by 40, because again, the 40s would cancel. 30 over 40 would simplify down to 3 over 4 soy. So the opportunity cost for 1 pound of corn is 3/4 of a pound of soy. And again, we can do the same thing except in terms of a single pound of soy. And so if we get rid of these here and we say, okay, well, we know that this 40 pounds of corn is equivalent to 30 pounds of soy, but we want to get this over here just to say 1 pound of soy. Well, we can divide that side by 30 and divide this side by 30. And in doing that, we get 1 pound of soy is equivalent to 40 over 30 simplifies into 4 over 3 pounds of corn. And so we get 4/3 pounds of corn. And again, we mentioned this before, but if you notice, these are just reciprocals of one another, and that's always going to be the case. Now, the reason I said I like doing this first is because it actually helps us solve some of these other questions a lot quicker. If you look up here, what's our opportunity cost for 12 pounds of corn? Well, we already solved for our opportunity cost for 1 pound of corn, right? So let's just multiply that out by 12. If we know that our opportunity cost for a single pound of corn is 3/4 pound of soy, and then we just can multiply this by 12 over here, multiply this by 12 over here, and you get 12 pounds of corn, right here, 12 pounds of corn, 3/4 times 12. And so what we can, you can plug that into a calculator. You can just say, what is 3/4 of 12? Well, it would end up being 9 pounds of soy, right? Or also what you can do is you can do 3 times 12, right? And it would get you 36, 36 over 4. Then you get the 4 out of there and it becomes 9 pounds of soy. You can do that same thing for this question down here. What is our opportunity cost for our first 10 pounds of soy? Well, again, if we know that the opportunity cost of a single pound of soy, right? So 1 pound of soy is equal to 4/3 pounds of corn, right? That's what it tells us right here. We want to know for 10. Well, then you just multiply both sides by 10, right? Multiply that side by 10, multiply that side by 10, and you get 10 pounds of soy is equivalent to 40 over 3 pounds of corn. If you plug that into a calculator, 40 into 3 actually ends up being 13 1/3 pounds of corn. That's 40 over 3. And finally, this one doesn't involve as much math. It just involves us moving from point to point. And so that's why we saved it for last. The opportunity cost of moving from E to B. And so if we look at points E and B, and so again, point E right here, and the direction is you have to be very careful paying attention to the direction. Moving from E to B, right? So what are we gaining? Well, we're gaining corn because we go from 8 corn up to 32. That's adding 24 corns. How many pounds of soy then do we have to give up? Because that's our cost. Whatever we have to give up is our cost. We're going from 24 to 6. that would be giving up 18 pounds of soy. And again, we have to pay very careful attention to the direction in which we're moving. We're going from E to B. Now it says, how do we describe the opportunity cost of this production possibilities curve? Well, is it increasing or constant? And again, I want to show you, if you notice here, every single time we add 6 soy right here, right? Every single time it's plus 6, plus 6, plus 6, right? What's happening to the amount of corn that we would be giving up every single time? Or what we are saying is, what's our opportunity cost for every 6 soy that we add? Here we give up 8. Here we give up 8 and 8. We give up 8. Every single time we're giving up 8. And therefore, since it's every single time, it's constant. And we can see that that is also true. We can see that this is constant through looking at this table and how those numbers stay the same, but also the fact that our opportunity cost, or our production possibilities curve is linear. It's a straight line. Our slope stays the same the whole time, because every single time we go over by, let me make sure I'm doing this right. We go over 8, we go minus 6 plus 8, minus 6 plus 8. Every single time it stays the same, right? That stair step stays the same. So therefore, our opportunity cost is constant through all of that.